Ever just stop and think about what's actually happening when you flip a light switch? It seems so simple, but there's this incredible, invisible journey that electricity takes to power our world. In this explainer, we're going to follow that exact path, from the very start all the way to the finish. Let's get into it.
Right? It's a question we've all probably had at some point. You flick a switch and boom, a dark room is suddenly full of light. I mean, it feels like magic, doesn't it? But it's actually science, and it's a pretty fascinating trip that begins way before that light ever hits your eyes.
So to really get what's going on, we need to start at square one. We're going to trace that simple but super powerful path that electricity takes through something called an electric circuit.
So what is an electric circuit anyway? Well, the easiest way to think about it is like a racetrack. For electricity to do anything useful, like lighting up that bulb, it needs a complete, unbroken track to race around. That continuous path is the circuit.
And every single one of these electrical racetracks needs three basic things to work. You got to have a source for the power, a path for it to travel along, and a load. That's the destination where all the work happens. If you take away even one of those, the whole thing just stops. First up, you have the source. This is the starting line. For a simple circuit, this is usually a battery. You've got these tiny particles called electrons that are all bunched up at the negative end, just buzzing with energy, waiting for the signal to go.
Okay, so the electrons are ready to go, but they need a road to drive on. That's the path. This is your electric wire or cord. Think of it as the superhighway that connects everything together, guiding that flow of electricity right where it needs to be.
And where's it going? It's headed for the load. The load is the entire point of this journey. It could be your light bulb, your TV, your phone charger, anything that uses that electrical energy. In a light bulb, its whole job is to resist that flow of electrons just enough that it gets crazy hot and starts to glow, giving us light.
This slide shows you exactly how a switch controls everything. The best way to think of a switch is like a drawbridge on our electrical racetrack. When the switch is off, the bridge is up. That creates a gap, right? The circuit is open and the electrons can't finish their lap. But as soon as you flip that switch on, the bridge comes down, the circuit is closed, and the electricity can flow. And that's when the light turns on. Simple as that.
Okay, so we've got the basic parts down. But how do scientists and engineers actually draw these things out? Well, it turns out they have a kind of universal language for it, which is what we're going to look at next. It really does sound like a secret code, but it's true. Engineers all over the world use a special visual language to map out circuits. Instead of drawing a little picture of a battery or a light bulb every time, they use these simple, standard symbols to show the flow of electricity.
And here are the basics of that language. You can see the symbol for the source, for the switch, our drawbridge, the path, and the load. With just these few symbols, anyone, anywhere in the world can look at a drawing, what's called a schematic diagram, and know exactly how that circuit works. It's pretty much a universal blueprint for electricity.
Now, it's one thing to understand how electricity works, but it's way more important to respect its power. It makes our lives so much easier, but let's be real, if you're not careful, it can be seriously dangerous. So we have to talk about safety.
I bet you've seen something that looks like this before, right? It's called an octopus connection. See, every wall socket is only built to handle a certain amount of electricity. When you start plugging in tons of devices, you're basically asking for too much power. That can overload the whole circuit, make the wires get super hot, and potentially start a fire.
So what are the big safety rules? Well, number one, never ever touch an open or frayed wire. Obvious, but crucial. Keep your fingers or anything else out of sockets. Try not to run cords under rugs because they can get damaged and become a hidden fire hazard. During a thunderstorm, it's a good idea to unplug big appliances to protect them. And probably the biggest rule of all, water and electricity are a terrible mix. Never, ever touch a switch or an appliance with wet hands. Of course, all this electricity that we're using isn't free. It all adds up to that one thing we all get in the mail, the electric bill. But what are we even paying for when we get it?
So every single appliance you own has something called a wattage rating. You can usually find it on a little sticker somewhere on the device. Wattage, which is measured in watts, just tells you how much electricity that thing needs to do its job. Some devices are really thirsty for power, while others just take little sips.
Okay, let's take a number. 45 watts. Just by itself, that number doesn't really mean much, does it? Is that a lot? A little? Well, it turns out that 45 watts is about what a modern TV needs to run. So that gives you a real-world idea of how much power one of the most common things in our homes actually uses. So what your electric company does is they take the wattage of all your stuff and they multiply it by how many hours you use it all. That gives them your total consumption, which they measure in kilowatt hours. And the math here is really simple. The less energy you use, the smaller your bill is going to be.
Which leads us perfectly into our last section. Because once you know how this all works, you have the power to make smarter choices. You can conserve energy, which is great for the planet, and hey, save a little money while you're at it.
I just love this quote because it sums it all up so well. Every single time we save a little bit of energy, we're doing two fantastic things at once. We're lightening the load on the environment, and we're lightening the load on our wallets. It's a total win-win.
And the best part is, saving energy is actually pretty easy. Unplug chargers and things when you're not using them. A lot of them are vampire devices that suck power even when they're off. Don't just stand there with the fridge door open. Every second it's open, it's working overtime to get cold again. Be efficient, like ironing all your clothes in one go. And of course, a super simple swap to energy-saving bulbs can make a huge difference over time.
So, I'll leave you with this one question. Now that you know the whole journey, from the power source all the way to that switch right there in your hand, what's one small change you can make? What's one switch you can decide to turn off today? Not just to save power, but to be a more conscious part of this amazing electrical world we live in.